Okay, good morning, everyone. So there's really just two topics I want to cover today, and maybe we can make a little time here. So I'm just going to get right into it as far as some updates on weed control and sunflower. Okay, so just covering kochia and some updates on kochia really over the past couple of weeks, but I always like to show this picture when I get the opportunity. And we'll go and skip that. Okay, so most of you have probably seen this slide or various iterations of this throughout this winter, but we really just want to keep spreading the message about PPO or Group 14 resistance in kochia. So this is a slide from Brian Jenks out of Minot, and basically showing a susceptible population sprayed with, in this case, AIM at 1 ounce. The back pots are 2 ounces of AIM, 8 days after treatment with a susceptible population completely controlled, and then this four different resistant populations that had various levels of regrowth. So some of the things that I like to point out is that seems like a pretty high portion of resistance within some of these populations, but we still do control some of these plants, like this mott population. There's a couple plants that we do control, but overall, when we're talking field level management, we're certainly not controlling all the plants, and this is why we have a lot of concern with PPO resistance. And so these are that same picture, the exact same populations, just an added 6 days later here or 7 days later, and showing just the amount of regrowth in these resistant populations while that susceptible population there stayed dead. Same thing with sharpen. So I know we can't use sharpen ahead of sunflowers, but certainly several crops we use in a rotation. We're also seeing failure to control these same populations with sharpen. And so the same setup here, this 1X, which is 1 ounce of sharpen in the front, 2 ounces of sharpen in the back. A little bit more symptomology that we're seeing on these plants, but overall there is plenty of regrowth on both the 1 and the 2 ounce rate of sharpen. And then again, fast forward a couple days and just showing more regrowth here. And so so these are these plants were all sprayed back in the fall when Brian was kind of first exploring this issue. We do have several replications of very similar studies ongoing currently. I was looking at a bunch of plants here on campus this morning. Was not able to get pictures in time to upload any presentation or upload for a presentation, but we're certainly, from the foliar perspective, seeing the exact same thing here, that we're not controlling these populations in a post-emergent setting. I'll talk a little bit more about some other kind of early stages of research here in another couple of slides. But the first thing I wanted to show next is that this other picture that Brian has been showing of quite a bit this winter, and looking at a rate titration, in this case, just of AIM. So, we know that the 1 and the 2 ounce rate of AIM, we're not seeing control. What about some higher rates? This is a pretty standard testing protocol when confirming herbicide resistance, but we basically use a rate titration, and we're going all the way up to 16x or 16 ounces of AIM. And one of these resistant populations that this was tested on, failure to control kochia even at those higher rates. You can see these susceptible populations up front. We have a colleague up in Canada who's testing a population from Saskatchewan, and he has seen very similar results. He was looking at sharpen and seeing up to 32x resistance with sharpen. So basically, a quart of sharpen per acre is not controlling the population he's working with. We're doing the same thing here on campus with sharpen as well. And it's very, very early, but I will say that some very high rates of sharpen. We do have plants that look like they will grow out of very high rates of sharpen. So when we're talking about resistance, we're also talking about very, very high level resistance. So it's not going to be simply a matter of increasing the rate of one of these PPO inhibiting herbicides to get control of kochia. So I put this slide together probably back in late December, early January. Some of these question marks on the right are starting to become a little bit more clear, but I just want to kind of walk through this slide again. So on the left it's really what we know about these populations. I really talked about those first 2 bullet points. That second one down below it is the other thing we need to keep in mind, is that a lot of these areas that we are seeing, Group 14 resistant kochia, we have a pretty high prevalence of glyphosate resistance. So we still certainly have populations of kochia that we can control with glyphosate, and that is certainly great from a sunflower production standpoint if you can still use glyphosate in your burn down and control your kochia. But knowing that we might have glyphosate resistance stacked on top of PPO resistance, and that of course makes the burn down situation quite a challenge ahead of sunflowers. Really, it's probably going to put a lot of reliance on gramoxone for us from a burn down perspective if you have one of these stacked populations. So on the right here, some of these things that were kind of question marks, and the question marks will be lifted probably in another week or two. If we were given this seminar next week, we are in the process of testing the soil applied herbicides. And so this question comes about because we know with the pigweeds, like with water hemp, that is resistant to group 14 herbicides, we know that we'll have reduced sensitivity to things like sulfentrazone, which is Spartan, and then this is Valor, flumioxazin. Still pretty early, but we do think there's going to be some differences between the populations, and there may be some populations where these products aren't going to be as effective as we would like. But there are going to be some populations where it looks like Spartan will still be a good residual product for us. So again, we're probably a couple weeks away from solid information on that, and we'll be distributing that probably in email or crop and pest article form later on this spring. We're still working on this next bullet point, the resistance mechanism. As far as how widespread it is, we know we have populations from probably 7 or 8 counties. Probably a dozen to a dozen and a half different populations. It's certainly not every kochia population, but we do know we have several that we're dealing with. So just something to pay attention to if you like to rely a lot on something like Spartan Charge for your burn down ahead of sunflowers, and kochia control just doesn't seem like it used to be. We'd certainly like to take your phone calls and maybe explore testing those populations in the future, just to get a better handle on how widespread it actually is. So this slide here, this is looking at one of the pigweeds, in this case, Palmer amaranth. And I just really wanted to hit home a little bit more on this residual herbicide standpoint for a group 14 resistant population. Again, it might be different in kochia, but basically what we're looking at here is on the left side of the screen, we have a group 14 resistant Palmer amaranth. On the right side, we have a population that is susceptible to the group 14 herbicides. And what I basically did to make this simple is something we always do when we test for resistance is we determine an R to S ratio, or a resistance to susceptible ratio. So think of this as of how much more resistant is this population compared to a susceptible check. And so what we typically do with the amaranths or the pigweeds is we'll find that there's complete resistance to the foliar diphenyl ether herbicides, such as Flexstar, Cobra, and Blazer. But we also see resistance to the soil-applied herbicides, generally 3.5 to 6-fold resistance to soil-applied herbicides compared to the susceptible check. And this is what we're currently trying to determine with kochia is do we have higher resistance to soil-applied herbicides when we're failing to control these kochia populations with our burn-down products like AIM and Sharpen. So the other thing I like to point out is it's a little bit difficult for us to make sweeping observations compared to what we know about the pigweeds. And the reason for this is when we talk about group 14 resistance for the pigweeds, we know that's complete resistance to Flexstar, Cobra, and Blazer. Usually within the pigweeds, Sharpen will still control those populations. We're kind of seeing the opposite with kochia here. So we're having complete resistance to AIM, resistance to Sharpen. This is, again, another picture from Brian showing that Flexstar was still controlling this one population. Some of the plants I looked at in the greenhouse this morning, it does indeed look like all the diphenyl ethers. So that's Flexstar, Cobra, and Blazer. All of those products still seem to provide control of these populations if you're applying it to 1 to 2 inch kochia. AIM, Sharpen, Reviton, Vita, all those populations currently in the greenhouse are regrowing and look pretty similar. So we have about 10 different foliar PPO or group 14 herbicides in that trial, And basically the only ones I'm pretty confident for complete control would be, again, Flexstar, Cobra, and Blazer. So again, none of those we're typically going to use in sunflower. We're just kind of showing what we're looking at here, trying to determine the nuances with this group 14 resistance at this time. And that's what I basically try to convey with this chart. This is just all the different group 14 herbicides that we have available for use in crop production. And the diphenol ethers, again, this Lactafense Cobra, that's Flexstar. Blazer, seems the products in this gray group may still give us some pretty good control. All the other herbicides, we're still currently in the process of determining how effective they might be. So that was on kochia. Going to switch gears and talk about one project we're working on with the pigweeds. And so this next couple of slides I'm going to show come from a presentation that was given at the research forum, the Sunflower Forum, back in January. So I'm part of a project that's led by Quincy Law, a faculty member here on campus, looking at all the different group 15 herbicides that we have available for their control on pigweed species and then tolerance in sunflowers. So this project generated quite a bit of data last year. If you look at the QR code on the left and scan that, that'll bring you directly to his presentation. That's about 45 or 50 slides. And again, I'm not going to cover all that, but I want to give really a snapshot of some of the things that we're discovering or learning from this research. And I will show that QR code again at the end of this section, just for those who want to go and look at that full presentation. But the basis of this presentation is we're testing all the different group 15 herbicides that we can use in our various crops. Not all are currently labeled for sunflowers. So we have dual magnum and zidua that are currently labeled for use in sunflower. We are looking at Warrant and Outlook. Flufenicet, these are a couple of European trade names. This is Flufenicet is what we used to know as Define. So it's another group 15 herbicide. And we're also including Prowl or pendimethalin there as another herbicide to check with this research. We all and rounding out this treatment list, we have a non-treated, so basically a weedy check, and then a hand-weeded check with no weeds present. So 8 different treatments, but then we also looked at these same treatments with the absence of Spartan or with the Spartan rate that gave us 4 ounces of active per acre. So it's 16 different treatments. We did have 3 different site years, but that's essentially what we were looking at with this trial. A couple of the important takeaways I wanted just to point out today. In general, we did not see much visible sunflower injury. We could see the occasional pretty typical group 15 injury. Never really saw more than what we would rate as 10% injury. The sunflower plants did eventually grow out of this once we got to about the 4th set of leaves. But overall did not really seem to impact sunflower growth and development. Here's just one data slide from one of our sites. I simply chose this one because it's a mix of redroot pigweed and water hemp and had very high densities. And so this is on the bottom of the slide here on our chart. We have the 16 different treatments, but the way an individual column might read, so I'm going to focus here in the middle, pyroxasulfone, that's zidua. Above it, it says non-treated. What that means in this instance is no sulfentrazone. And then when it says sulfentrazone, that's zidua plus that Spartan. And then the different letters are representing different levels of control. And so on this chart, basically the best control was hand weeded. No surprise there. So we were really looking at, for the best control, all these bars that have the letter B above them. So where we had acetochlor with sulfentrazone, Outlook by itself, which I forgot to point out, this was accidentally too high of a rate of Outlook, which will be important when we look at some injury. And then one of the rates of zidua were some of the best control on pigweeds that we observed in this trial. We also did look at how a product performed by itself compared to the inclusion of Spartan, and both or all 3 of Warrant, Flufenicet, and then Prowl did see a benefit when we included Spartan. The rest of them we were pretty similar, but no noticeable or significant increase with that inclusion of Spartan. Quickly to show, this is a yield chart from one of our other sites. So we didn't take yield at all sites, but at this particular site, or I should say anywhere we took yield, we did not see a difference. I'm just simply showing from this site. So basically, the bars go up and down, but no actual statistical difference. So that's a good thing from a crop safety standpoint, is that we really did not see any of these Group 15 products that are not registered for use in sunflower cause injury or yield loss. We did also, for the non-registered products, we took seed samples from all the plots and sent them for residue testing. And so this is just some screenshots of what those reports look like. But the main point here is in red, is that acetochlor, which is Warrant, dimethylamine P, which is Outlook, and then flufenicet, which was the old product Define. We did not detect any residue in the grain that was sent off for testing. So basically minimal injury, no impact on yield, and then nothing found in the residue gives us some hope that those products might be able to be registered just for additional Group 15 options in sunflower. This was year one of the study. We are repeating it again next year. And so again, I wanted to just bring up the QR code there is on the left if you want to go look at the full results of that trial, and a couple of Dr. Law's favorite pictures from the trial. Anytime we have Palmer amaranth in a crop like sunflower, we can always find a few that like to showboat and grow taller than the crop itself. This might be my favorite picture here on the right. That is water hemp growing through grasshopper holes on a leaf. So where there's a will, there's a way with these pigweeds. And just a couple of pictures there, and really to buy some more time in case you wanted to scan that QR code. So with that, Greg, I'm done.